So today we're going to be talking about 1.2, which is measuring and constructing segments. And the first thing that we need to talk about is the ruler postulate. Before we even get into that, we need to know what a postulate is, or an axiom. I usually call it a postulate. Other people call it axioms. And what that is that's a rule that is accepted without proof. So it's been done so long, we don't have to prove it. A rule that can be proved is called a theorem. As you'll see later, postulate 1.1 shows us how to find the distance between 2 points of a line. So if you look at postulate 1.1, we don't have to prove this now, okay? It's accepted. So the points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of the point. So if you look here, you have point A and point B, but they could have a coordinate, an x coordinate, and an x2 coordinate. So an example of that would be, let's say if I had something like this, and let's say that this was 0, this was 1, 2, -1, -2, and I'm going to go ahead and put a point at -2, and then a point at 2, and then I'm going to connect this to make it a segment. So now, to find the distance between the two, really all you're doing is counting. So you can count from here. Let me change that out to an arrow. So I'm going to count from, now this was point A, right? So let's go ahead and put that in point A, point B. So if I want to count from point A, it's 1, 2, 3, 4. So the distance between points A and B, so really AB, segment AB equals 4 units. Now you don't always have to count. You can actually use what they have down here, which is this. So if you see, it's going to be the absolute value of 2 minus -2. So this is another way to find AB. So this would really equal 2 minus 2. Now, if you don't know, always add the opposite. So it's 2 plus 2, which would be 4. The absolute value is 4. So really, that's what they're trying to say here. That's what this means right here, okay? So you just take this value, subtract it from this value, and we all know that the distance from, anytime we take a distance, it's always positive. So that's why we use the absolute value here. So the next thing we're going to get into is congruent segments. So if you look at this definition, line segments that have the same length are called congruent segments. You can say that the length of segment AB is equal to the length of segment CD, or you can say that segment AB is congruent to CD, segment CD, same exact thing. Now the symbol that we use is this symbol right here. It's 2 lines with a squiggly mark on top of it, okay? So if we're going to use the equal sign, where it says the lengths are equal, so if we said that from the distance from A to B is equal to the distance from C to D, we'd use the equal sign, is equal to. Now if we're talking just about the segment, so if we're just talking about segment AB and segment CD, we would say segment AB is congruent to segment CD, is congruent to. So if you notice the little squiggly line, it really is the same. It's tough to see, it's kind of small, but it's this right here. It's this symbol right here. That's the congruent symbol. So let's look at an example with congruent segments. So what they want us to do is they want us to plot J, plot K, plot L, and plot M. Then determine whether JK and LM. So what I did is I went ahead and plotted them all. I plotted J, plotted K, plotted L, plotted M. And then it says the segment JK, so all I did was connect the 2 points J and K, and then connect the points L and M. So I have those 2 segments. So now what they're going to ask us is determine whether JK and LM are congruent. That means, is this segment the same length as this segment? Now there's 2 different ways you can do it. Probably the easiest way you might think is, well, Mr. Deschel, can I just count from J to K? Yeah, and you absolutely can. So go ahead and go 1, 2, 3, 4, 5. So that means I know that JK, segment JK, equals 5 units. And now let's go ahead and count from here. So 1, 2, 3, 4, 5. So LM, segment LM, is also 5. So what that means is I can go ahead and say that JK is congruent to segment LM. So remember, now we know that this is true. We call this the ruler postulate, okay? Because you're really using your concept of using a ruler. You could pull out a ruler and you could go ahead and measure it. So that's the ruler postulate. Now I'll show you something a little bit different. We know that if I take a look at JK, if I want to go ahead and say that JK, now remember what I talked about for absolute value. I can just take the x values for JK and say, okay, say if I want to go, what is the x value here? X value is 2. So I'm going to go ahead and say 2. And remember, I was going to subtract. To find distance, you want to subtract. So 2 minus -3. That's a 3. I know it doesn't really look like it, but 2 minus -3. And remember, we always want to add the opposite. That's the subtraction rule. Add the opposite. So 2 plus 3. So I know that this will be the absolute value of 5. What's the absolute value of 5? Well, it's 5. Now I can do the same thing with LM. If we look at LM, I want to go and use the y values this time. Okay? So for this one, when you go up and down, you want to use the y values. Okay? So you want to go ahead and say -2 minus 3. All right. Still want to go ahead and use the concept of add the opposite. So add the opposite. So it's -2 plus -3. Now when I have two negatives, all I have to do is add those together, and you get the absolute value of -5. And I know the absolute value of -5 is 5. So if you notice, I can say that JK is congruent to LM. And make it congruent a little bit better. I know with the styles it's tough. It's a little squiggly line like that. So JK is congruent to LM. So that's the symbol you want to use right there. So hopefully you have some graph paper. What I want you to do is try this example. I want you to plot A, B, C, and D in the coordinate plane, and then determine whether A and B, segment A and B, and C and D are congruent. So pause here, try to figure it out, and then I'll continue the work on the example. Alright, so what you want to do is you want to first go ahead and plot your points. I'm going to make this a little bit bigger. Plot your points, and we're going to go ahead and say that -2, 4 is 2, 4 is right here. And make sure you just stick the A right there so you know what it is. And then B is 3, 4, which is right here. So that's B. And then we want to go ahead and plot C, which is 0, 2. So C. And then 0, -2, which is right here. So that's D. Now you want to go ahead and go back and connect them. So I want to go from here to here. So that's your segment AB, and then you have your segment CD. Now it says determine whether they are congruent. So what you want to do is you can do it either way. You can count it, or you could go ahead and use the ruler postulate. So if we have, I want to find out what AB is. I'm going to say AB is the absolute value. Now I'm just doing the x value, so it's going to be, you can really do in any order you want. I'm going to do -2 minus 3, and remember I always want to add the opposite, so that means I'm going to get -5. What's the absolute value of -5? Well, it's 5. So I know that AB equals 5. So now we need to go over and figure out what CD is. So CD, I want to do the absolute value. Now I'm just doing the y values. So the y value of this is 2 minus the y value of D, which is -2. And we always subtract, because to subtract, that's how you find the distance of something. Now I want to add the opposite, and you should get CD equals the absolute value of 4. 4. So CD equals 4, and we knew that AB equals 5. Now we can say they're not congruent. You just determined that they weren't congruent. So you can just write not congruent. Good job. So what I'm going to show you now is using the segment addition postulates. Remember, this is a postulate. We don't have to prove this. This is known. Okay, so when 3 points are collinear, now we know collinear means on the same line, you can say that 1 point is in between the other two. So if you look at this right here, we have point P is between A and C. If you look at this example, line DF, we know that point E is not between point D and F. Okay, it's not on the line. It has to be collinear on the line. I know it's kind of straightforward, but I need to show you that so I can show you the postulate, which is the segment addition postulate. If B is between A and C, then C equals AC. So AB plus BC equals AC. So if you look at this example over here, if you take AB and then BC, this measurement plus this measurement will give you the whole measurement. So if AB plus BC equals AC, then B is between A and C. So I'll give you an example of that now. So here are a few examples for you. If you want to pause and try it on your own, you can pause now, or I'll walk you through it step by step. So if you look at this, we have find DF. We want to know what the distance from D to F is. And what that means is the postulate is segment DE plus segment EF equals DF. So if I know what DE is, I know that DE is 23. And if I know what EF is, or segment EF, is 35, well, you just add those up. So 23 plus 35 is 58. So that means that segment DF equals 58. Alright, so now on to part B. So if I know that I have to find out this is, to use the segment addition postulate, we know that, I'll start with FH this time, FH, so the whole segment equals FG plus GH. Now let's go through and figure out what we know. Well, we know what FH is. We know that FH is 36. I know that FG is 21. But I don't know what GH is. So if you think about it, all you have to do is subtract 21 from both sides. So 36 minus 21 is 15. So we can see that GH equals 15.